Hi everyone, I'm Zach Thomas, and this is our demo for our 124 project, Local Legend. Local Legend is a surf report website with AI-powered recommendations. Let's get into it. So here are the 10 features that we're going to go over in this demonstration: user authentication, geolocation services, data aggregation from major national weather services, AI-powered overviews, and AI-generated predictive recommendations of the best time to go surfing. We're also going to talk about our favorites page that allows users to add beaches as their favorite so that they can quickly see conditions. The Explore page that allows users to discover new beaches, push notifications for receiving updates on current conditions, Google Maps integration for navigation, and image gallery for seeing pictures of the beaches. All right, let's get into the demo. So when users first land on our website, this is what they're going to be greeted with. They're going to see the current date and their current location. They're also going to see the current conditions at a nearby surf beach. So there are the conditions that we track in our application are wave height, which is represented by swell, wind conditions, and tide conditions. So here they can see at Main Beach down in Laguna that this wave height is about 3 feet, that the wind is coming out of the southwest at 5 to 10 miles an hour, and that the tide is going to be low at 3:58 a.m. Beneath that, there's an AI-generated summary of the conditions at that beach. To log in, users click on this user profile icon, which takes them to the login page. If they're not registered, we also have this registration page that allows them to fill out the information and get authenticated. Since I already have a test user, I'm just going to put in that data or that information. Test. Right. Once logged in, we take them back to the main homepage. Um, the current conditions on the homepage are updated periodically, and they stay updated. All right. So to see the forecast of a nearby beach or a beach that you want to go surfing, you come over to the forecast tab. Here you can enter the name of the beach in plain language search. So here we're going to look at the weather conditions at Zuma Beach. So we put that in, it generates the results. Cool. Up top, we have images that have been generated by people who've gone to this beach using the Google Places API. Underneath that, we have the current conditions at Zuma Beach. So we got wave height of 2.3 feet, wind speeds of 10 miles an hour, and low tide at 4:11 a.m. Underneath that, we're going to have our AI-generated surf report that's going to provide a recommendation of the best time to go surfing. Here you can see that it's looking like Tuesday morning is going to be the best bet to go out to Zuma. Underneath that, we have a button that links you to Google Maps and provides you directions on how to get from your current location to the beach that you're interested in. Up top, we also have a share button that allows users to copy the link to this surf report along with sharing it on Facebook, as you can see here. Boom. It's, we also have this heart icon that allows users to favorite a beach. When it's not filled, the beach isn't favorited, and when it's filled, it's favorited. When you favorite a beach, it gets added to your favorites over here. Here you can see a list of 4 local favorite surf spots. So we got Doheny State Beach, Zuma, El Porto, and Venice. And it shows the different conditions at each of the different beaches. Over here, you have the bell icon to set up notifications. So you can set up to receive browser push notifications about current conditions at each of the different beaches. So let's say that you want to get updates on Tuesday evening about the conditions at Doheny State Beach. You hit 2, you hit evening, you hit save. It's as easy as that. All right. Over here on our user profile, this is where the user can go in and update their preferences and how they want to receive messages, their skill level, and their general information. Finally, over here we have the Explore Spots page that allows users to find out about beaches around them. So here you can see that we're getting results for Laguna Niguel, which is where I'm at. So you can see San Onofre, Doheny State, and Huntington Beach. We have images of each of the different beaches taken from Google Places, along with a short summary about that beach. All right, let's talk about how we made this application. On the front end, we're using React, Bootstraps, and Axios. On the back end, it's based on Node.js and Express. We're hosting this on Google Cloud Platform, so we're using Cloud Run and Artifact Registry for hosting this. And the front end is hosted on Firebase, and Firebase is also taking care of our user authentication and hosting. We're using a lot of different web APIs. So we're using Google Places, geocoding, and generative language. From the different weather services, we're pulling from each of their APIs to generate that aggregated report. Here's the architectural overview of our system, but let's go into the Figma and dive more into our architecture. So starting with the system context overview, you can see our general application and how it interfaces with both GCP services and APIs from a couple different national weather services. In the container diagram, we're able to see that we have this React front-end application and it interfaces with our Node.js backend that's running on Cloud Run and our database that's Firestore, along with the outside services provided by GCP and the National Weather Service. Down here in our component diagram, you can see each of the different services that make up our Node.js backend. We have Gentext services that's responsible for generating those AI overviews and predictions. We have the condition services, which is responsible for going out and aggregating the data from the different weather services. So you can see it's talking with a lot of different endpoints from those different agencies. The location service is mainly responsible for taking plain language searches and converting them into latitude and longitude coordinates and vice versa, along with pulling information from the Google Places API to gather information about the different beaches. The Explorer service, which runs on that Explore page, is also interfacing with the Google Places API. And the favorite services and the user controller, it's saving user data to the database. And the notification is using cloud messaging to send those browser push notifications. All right. So I feel like we got a lot done this term, but this project could be taken in a lot further. First off, our notification services is only doing browser push notifications. We initially intended to send SMS and email notifications, but we ran into some regulatory hurdles. You actually have to register your service with the mobile carriers in order to send SMS messages to users. So we couldn't do that for this project. The explore functionality is kind of limited. We intended to generate overviews of the different beaches, but we really weren't able to do that. So we just kept it simple. Weather data is very sketchy. We're pulling from those National Weather Service services, but we're not really doing a great job of interpreting or aggregating that data. So there's a lot that can be improved there. Also, our AR prompts are pretty simple. We're basically just feeding in that weather data into the prompt and asking it for a recommendation. So a lot could be done there. Also, we didn't really do any testing or CI/CD. We basically worked on our features, committed them to our GitHub repository, and manually deployed them on Google Cloud. All right. Thank you for um, look, watching our demonstration. I hope you think our app is useful. Thank you.